So in this short video, we'll study about the derivation of laws of reflection by Huygen's principle. So what are the laws of reflection? Angle of incidence is equal to angle of reflection, and reflected ray, normal and incident ray, they all lie in the same plane. So by Huygen's principle, we will derive this formula and we will prove how these are actually equal. So we know, so to start this all, we'll first draw a normal reflecting surface like a mirror. Then we'll draw two rays coming from infinity. So this is ray number 1, this is ray number 2. So now we'll draw the normal is perpendicular to the reflecting surface. So this is normal, this is normal, this is normal. So now in Huygen's principle we studied about wavefront. What is wavefront? Wavefront is the points at same phase, points of waves at the same phase. So, and we also learned that wave fronts are perpendicular to the ray of light, which means if the ray of light is going like this, then perpendicular means perpendicular. If like this is ray of light, then perpendicular surface like this surface, this is wavefront. So this is one wavefront, like this point is wavefront perpendicular to it. So now over here, if I draw a wavefront, where from this point, if I draw a wavefront where the ray 1 is striking the reflecting surface, and it says what? Perpendicular. So I'll draw it perpendicular. What is perpendicular to here? This is perpendicular. You know, this is perpendicular, and these two rays are parallel. These two rays, ray 1 and ray 2, are parallel. So therefore here also it is 90 degree, right? Same way over here. If I have to draw wavefront over here, perpendicular to this reflecting surface. So this reflecting surface I'll call as A, this reflecting surface I'll call as C. Okay, so at A I draw a wavefront perpendicular to this and this, because these two are parallel. I'll draw a perpendicular wavefront at C also, and these two are also parallel, so it will also be perpendicular to this. So if I draw it, it will become like this. You see, here also 90 degree, here also 90 degree, same way. Now I'll call these points as B, and this will call point as D. So now let's generally know what is in a mirror. In a mirror, we know what is the angle of reflection, angle between the normal and the incident ray. What is this? So this is what? Angle I, angle of incidence. And over here, what is angle of reflection? Angle between the reflected ray and the normal. So this is angle R. Okay. So now if you see properly, this angle from this normal to this ray is angle I, and this normal to this reflected ray is R. Let me just make it clear. Okay. Now what is this full angle? This full angle is what? 90 degree, right? Agree? So this full is 90 degree, and this is I. So what is this? So what if I have to find this angle? What if I have to find this angle, like this minute angle between the normal and the wavefront, between the normal and the wavefront? We know what is wavefront and to reflected ray, 90. This full is what? 90, and this small part is what? I. Then what is this? 90 minus I. We can say if this full is 90, this section is I, then this is 90 minus what is present over here, right? So can we say this is 90 minus I? Can you say like that? Now we know the angle between the normal and this wavefront is 90 minus I, and we know angle between the normal and this surface is what? Also 90, right? So now wait, I'll clear this again. So now it is this way. Okay, now it is, I'll show again. Okay, now again, this is incident ray, the ray is going somewhere here, reflected ray. This is wavefront, this is wavefront. Okay, this is wavefront. Now if this is what? I, this is 90 minus I, because what? This full is 90, and this one section is I, then this other section is 90 minus what is present over here? I. So 90 minus I. So now what if I have to find for this angle? What is this angle? What will you do? So now we know this full is what, 90. Why is it 90? Because this is normal, this is surface 90. Now this portion is what, 90 minus I. 90 minus I. If this is full I, if this full is 90 and this is 90 minus I, then this is I. Imagine like this is what, 90 degree, right? Now if I draw one line, then this I got is 90 minus I, right? Then this I can say it is I. If this is I, then this can be 90 minus I, right? Same way, if this is 90 minus I, this is I. Just the opposite of that. Just how we found here I is equal to, here I, so here 90 minus I. What is the opposite of that? I, 90 minus I, this is I. Same way over here, this is wavefront, this is wavefront, DC is wavefront, and this refracted ray, and this normal is R, right? So over here is what, 90 minus R. 190 minus R. This full is 90. One section of this is R, then the other section of this will be what, 90 minus what is here, R, so R. And over here again, this is normal, this straight line is normal, this is diffracting surface, so it is in the form of like this. If, and then I got what, this is wavefront, this is 90 minus R. If this section is 90 minus R, then this is R, opposite of what we took it before. If this is R, then this is 90 minus R, then this is R, like just opposite. Like if this is 90 minus R, this section, then this is obviously R, because this full is 90, this is something minus some 90, then this is probably that something that we are subtracting to get this angle, right? So now this is what, R, this is what, no, this is R, this is I, this is 90, this is 90. So now if I clean this image again, okay, if I draw this image one more time with all the angles and all properly, okay. So if this is the reflecting surface, and this is going one, this is going second one, then this is the normal, this is another normal, and if I have to draw wavefront is what, perpendicular, here also wavefront, from this surface over here is perpendicular, this is A, and then this is C, this is I'll call as B, this I'll call as D. If this is I, this is 90 minus I, this is R, I. If this is R, this is what, 90 minus R, this angle between normal and this, okay, it's small because the diagram is small, but if you draw it big, then you get it big. Then over here it will be what, R. This angle is what, 90, this angle is what, 90. Now you can see two triangles. Which two triangles? One is this, right? What is it? A B C. Next one, this what, ADC. In triangle ADC, what can you see? What can you see in ADC? Angle B and angle D are 90 degree, right? Angle B is equal to angle D is equal to what, 90 degree. Now AC is common for both, base, so AC is equal to AC, common. Now listen, what is wavefront? At equal points, the point at equal phase, at same phase, means at same time. So if I take one wavefront here, so this ray traveled from this wavefront to where, to C, right? So if this, I call it as what, distance, if I call it as, okay, so foot distance, I can just call it as distance x, okay, but we have to, yeah, okay, fine, we'll just call this distance x. So from B to C it traveled distance x, the ray of light. Then from A to C, from this also wavefront, right, it reflected, and then it's still traveling from this wavefront to the second wavefront, it traveled x. So from this wavefront to other wavefront, it's also x. Now how will, like, it will be x, same phase, this is same phase, right? Both are in same phase, so the distance traveled will basically be the same. Because this both are wavefront at the same time. If this is at 0, if this is the wavefront at t is equal to 0, then this is the wavefront at t is equal to 1. Okay, what time is, for both time is equal, they covered equal in equal amount of time. But then what, if the velocity of the ray is what, v, then they covered v in time 1 second, these both. same way. So we can just say both are same distance, same length, same displacement of the ray. Then what is this? BC, it covered this. BC covered from this wavefront to this wavefront. So BC is equal to what? AD is equal to AD. BC is equal to AD. So now two sides and one angle is equal. That angle is 90 degrees. So by RHS theorem, these two triangles are congruent. These two triangles are congruent. When these two triangles are congruent, means they are perfectly similar. So if I take any angle, example I take angle I, then it will be equal to angle corresponding to it, angle R. Simple. This is the first